Imagine really transforming your data. I mean, not just storing it, but making it this dynamic, intelligent engine that generates insights, maybe even content, right when you need it. We're talking about a pretty fundamental shift in how you get value out of all that information you're sitting on. So today we're doing a deep dive into Supercharging Snowflake with LLM Power. It's all about these large language models, LLMs you hear so much about, and how they're genuinely changing things for data platforms like Snowflake. Pushing the boundaries, really. And our mission here is simple. Give you a shortcut. Help you get properly informed about this. We want to cut through the hype and the technical jargon, show you what LLMs actually are, why picking the right one is, well, critical, and the exciting part, how they're being used right now in real enterprise setups. The goal is for you to understand how these AI models can genuinely lead to better results for you and potentially, yeah, some significant cost savings too. Okay, so let's kick off with the core idea. We all hear large language model, LLM, all the time. But what actually makes them large?
And why does that scale unlock things humans just can't do, especially with enterprise data?
Well, at its heart, an LLM is an advanced type of AI model. The large part comes from it being trained on just massive, colossal amounts of text data. And because it's seen so much text, it gets incredibly good at understanding, generating, and manipulating human language really fast, really fluently. The key thing for you is that it handles these complex language tasks at a speed and scale that's just, well, it's impossible for people.
Right, and that scale, that power, immediately brings up a really crucial point. You mentioned choosing the right LLM. It's not just a tech choice, is it? Our sources really stress this. It's strategic. It can directly hit your bottom line.
Oh, absolutely. That's a critical point. Optimizing your investment means realizing that maybe a smaller, more specialized model could be way cheaper and faster for one specific job than some giant general purpose one. And that choice directly impacts your costs, your operating expenses, and frankly, how quickly you actually get the insights you need. There are several key factors that guide this choice. First up is parameter size.
Parameter size.
Yeah, think of parameters as sort of the AI's accumulated knowledge points. So a model like GPT-4 with maybe around 1 trillion parameters. It's absorbed a staggering amount of information. That makes it incredibly versatile.
But I guess that huge size, that versatility, it comes with a hefty price tag, right?
Okay.
Computationally speaking. It's a balance power against budget.
Exactly. Then you've got the context window. This is basically how much information, think words or parts of words, tokens, the model can kind of hold in its head and process at one time.
Okay, so bigger window, better for understanding long documents or back and forth conversations.
Precisely. Then there's the focus area. Is the model a generalist or is it specialized in something specific, like medical text or code generation?
Makes sense. What else?
Customization. This is huge. Can you actually tweak the model? Can you fine-tune it with your own data to make it better for your specific tasks?
Right, tailoring it.
Then, licensing. Seems boring, but it's vital. It dictates how you can use the model, especially commercially. Protects IP, ensures ethical use, guarantees support sometimes. You really need to check the license.
Jeff, they don't want to get caught out on that one.
No. And finally, the offering. How is the model actually provided? Is it something you download and run yourself? Or is it typically as a service where you access it through an API?
Like calling out to a service someone else runs.
Exactly.
Right.
As a service model is very common.
So before you even dive into comparing models like GPT versus Llama, our sources say you need to ask yourself some tough questions first.
Yeah, that's really important groundwork. Things like, what's my primary use case? What am I really trying to do here?
Okay.
What's the scale? Am I processing a few documents a day or millions? What's my specific domain, finance, healthcare, retail? The language matters.
And crucially.
And what resources do I actually have? Budget, technical expertise, infrastructure. Answering those up front stops you from, choosing a model you can't actually afford or manage effectively.
Right. Avoids costly mistakes down the line. Okay, so with that foundation, let's get into the specifics. Let's compare two big names everyone knows. GPT, maybe specifically GPT-4, and Llama 2. What are the pros and cons?
Okay, GPT-4, it's undeniably impressive. Its reasoning, its ability to understand context, it's exceptional, really versatile. Plus, a big pro is that it supports fine-tuning. You can adapt it to your specific domain, which is fantastic for niche tasks needing high accuracy.
But there's always a but, isn't there? The downside.
Yeah, the main one is cost. For heavy enterprise use, GPT-4 can get quite expensive, and it's computationally hungry. It needs significant resources to run efficiently, especially at scale.
So power comes at a price.
Let's look at the specs for GPT-4. You mentioned roughly 1 trillion parameters.
Around that, yeah. It has flexible context windows, typically 8,000 or even 32,000 tokens. Its focus areas are really broad: NLP, translation, text completion, code generation, you name it.
And customization licensing.
For customization, there's a model index for research, and it operates under the OpenAI license agreement, usually offered as a service.
Okay, got it. Now let's switch gears. What about Llama, or specifically Llama 2? What's its story?
Llama 2 often appeals because, well, it can be more cost-effective, particularly for research or development phases. And a huge factor is that it's open source.
Open source,
Yeah.
meaning the code is public.
Exactly. That fosters a big community around it, lots of innovation, and it gives you the potential for really deep customization if you have the skills. You can really tailor it.
That sounds pretty appealing, especially the customization part. What's the catch?
Well, the flip side is it generally requires more in-house expertise to deploy it, manage it, and fine-tune it effectively. It's not quite as plug and play. And generally, for massive scale commercial use, it might be seen as perhaps less powerful overall compared to the biggest proprietary models like GPT-4.
Okay. And the specs for Llama 2?
It comes in various sizes, which is interesting. You see versions like T5 small, base large, even 3 billion or 11 billion parameters, so there's choice there. Its typical strengths are often cited as machine translation and document summarization, and it's frequently fine-tuned specifically for chat or conversational AI purposes.
License offer.
It uses the Apache License 2.0, which is quite permissive, and again, it's often available as a service through various providers, or you can host it yourself.
Right. So different strengths, different models. How do we visualize which type of model, maybe based on its architecture, is best for what job? I saw this LLM use case matrix mentioned.
Yeah, that's a helpful way to think about it. Different underlying architectures like encoder-only, encoder-decoder, decoder-only are inherently better suited for certain tasks. For example, encoder-only models like the classic BERT are really good at understanding text deeply. They're like deep readers, great for things like text classification or pulling out specific information. The matrix lists them as somewhat effective for text summarization and conversational AI. They can do it, but it's not their primary strength.
Okay, so they read well. Then you have encoder-decoder models like BART.
Right. These are designed to transform input text into output text, making them naturally good for tasks like translation or summarization. They get an average rating in the matrix for summarization and conversational AI.
And then the decoder-only models like GPT-4, these seem to score well across the board.
They do. They are master generators. They excel at taking a prompt and creating new, coherent text. That's why they're marked as good for a whole range of things. Summarization, conversational AI, document Q&A, text classification, code assistance, even general content generation.
It's interesting that decoder-only, like GPT-4, seems so dominant across so many common use cases. Why is that, fundamentally?
Well, I think it comes down to the fact that so many valuable enterprise tasks right now involve generating human-like responses or content. Whether it's answering a question, writing an email draft, summarizing a meeting, or powering a chatbot, the core need is often coherent text generation, and that's precisely what decoder-only models are built for.
That makes sense. It's all about the output in many cases. Okay, so we understand the models, the choices.
Yeah.
How does all this incredible LLM power actually get plugged into a platform like Snowflake? How do you make your data AI-driven there?
That's where it gets really practical and powerful. One of the coolest things is that Snowflake offers native LLM access directly through something called Snowflake Cortex.
Cortex, okay.
Yeah, these are essentially built-in models already optimized to work within Snowflake. You can use them straight away for tasks like summarizing text, answering questions based on your data, generating text, all without ever leaving the Snowflake environment.
That sounds incredibly convenient. No complex integrations needed for those basic tasks.
Exactly. But what's also great is the flexibility. You also have the option to connect to external LLM providers. Think OpenAI, Azure OpenAI, Anthropic, whoever.
How does that work?
You can use their APIs, typically integrating them via Snowflake's external functions. This means you can pick and choose, maybe use a specific external model for a highly specialized task, while still keeping everything managed within your Snowflake setup. You get the best of both worlds.
So, native options for simplicity, external options for maximum flexibility. What can these LLMs, whether native or external but inside Snowflake, actually do for you? What are the killer apps?
Oh, the applications are really powerful. They genuinely speed up how you get value from your data. For starters, they can directly answer questions using the information stored in your Snowflake tables.
Like a natural language query interface?
Kinda, yeah. They can also generate text think, drafting emails, writing reports based on data, generating SQL code suggestions, or summarizing long documents or tables. Plus, translation on the fly, extracting key bits of information from unstructured text stored in Snowflake, running sentiment analysis across customer feedback.
Wow, okay. Sentiment analysis directly on the data warehouse. That's interesting.
It is, and of course, powering sophisticated chatbots or conversational AI interfaces that have direct access to your structured and semi-structured data.
Just thinking about that,
Mm,
it really could change how people interact with their data day to day, couldn't it? Making it much more interactive.
absolutely. More dynamic, more responsive, less about writing complex queries all the time, maybe more about asking questions.
Let's make this concrete. Can we walk through some practical examples of actually using these LLMs in Snowflake? Maybe starting with that native Cortex approach.
Sure, a native usage via Snowflake Cortex is honestly remarkably simple, especially if you're comfortable with SQL, because it's fully SQL-based.
No external API calls, nothing complex.
Nope. You use a specific SQL function called LLM complete.
LLM complete. Okay.
So imagine you have a table, let's call it input prompts, and it has a column named prompt text. You might insert rows like, explain what is data engineering, or summarize the benefits of cloud computing.
Right. Just simple text prompts in a table.
Exactly. Then, in your SQL query, you'd simply write something like, select prompt text LLM complete GPT-4 prompt text as generated response from input prompts.
So you just call the function, tell it your model, maybe pass in the prompt column.
That's it. And the output would appear right there in your results. For explain data engineering, you'd get a clean, concise response like, data engineering involves designing and building systems to collect, store, and analyze data efficiently.
And for the cloud computing one.
Something like, cloud computing offers scalability, cost savings, accessibility, and flexibility for businesses. It's immediate generated text right within your SQL query results. Super straightforward.
That is simple. Okay, what about the second way? Integrating with external LLMs, maybe using Snowpark Python and something like the OpenAI API.
Right, this is more of a client-side approach, often using Snowpark Python. Now, Snowpark is really cool. It lets you write and run Python code directly within Snowflake's environment.
So the Python code runs close to the data.
Exactly, bringing the compute to the data. It's great for more complex logic, or in this case, integrating with external services. Now, it's worth saying, for really robust production setups where you're sending potentially sensitive data out, you'd often use Snowflake's external functions feature, probably routing through an API gateway for security and governance. That keeps things tightly controlled.
Okay, good caveat for production. But for development or certain use cases, Snowpark Python works.
Absolutely. You'd write a Python function, maybe using the OpenAI library, that takes a prompt, calls the OpenAI API, and returns the response. Then you can register this function in Snowflake and apply it to your table data using Snowpark data frames.
So similar prompts like explain data engineering.
Yeah, and the output generated via the external API call might be something like, data engineering is the practice of designing and managing data workflows, pipelines, and architectures to enable data analysis and decision-making. Slightly different phrasing, maybe, depending on the model settings.
And for summarized cloud benefits.
You might get, cloud computing provides scalable, flexible, and cost-effective computing resources accessible from anywhere, improving efficiency and reducing infrastructure management. Again, concise and useful.
So native for simplicity, external via Snowpark, or external functions for more control or specific models. Now you mentioned automation, making this happen automatically. That sounds like the real game changer for efficiency.
It really is. You can fully automate this LLM processing using Snowflake streams and tasks.
Streams and tasks, how do they work together here?
Okay, so first you set up a stream on your input table, the one with the prompts. A stream basically just detects new rows that get inserted into that table. It flags them.
So it knows when new prompts arrive.
Exactly. Then you create a task. A task is like a scheduled job in Snowflake. You could schedule it to run, say, every 5 minutes. And the task's job would be, check the stream for new rows. If there are any, grab those new prompts, run them through the LLM complete function or your external function call, and insert the prompt and the generated response into an output table.
Okay, so the stream spots the new work, the task picks it up automatically on a schedule, and processes it using the LLM.
Precisely. So if someone inserts a new row into the input table with the prompt, what is the future of artificial intelligence, they don't have to do anything else. Within, say, 5 minutes, the stream detects it, the task runs, calls the LLM, and the output table automatically gets a new row with the prompt and the response, maybe something like, The future of AI includes advancements in autonomous systems, ethical AI, and enhanced human-machine collaboration.
It's like having an automated insight generation pipeline running constantly in the background.
That's exactly what it is. Fully automated data enrichment or analysis using LLMs, triggered by new data arriving. It's incredibly powerful for keeping things up to date.
Wow. Okay, that really paints a picture of how integrated and automated this can become. So that pretty much wraps up our deep dive for today then. We've gone from really understanding what large language models are, why choosing the right one is so important strategically,
Yeah, looking at those key factors like parameter size, context window, licensing,
all the way through to seeing how practically they get integrated into Snowflake, both natively with Cortex and using external models.
and seeing those concrete examples using SQL, Python, and then automating it all with streams and tasks.
Right. And the core message really seems to be that this seamless integration fundamentally changes how you can get value from your data.
Hmm.
It makes these complex analysis and content generation tasks just simpler, faster, much more impactful.
It really does. It's a significant step up in how we interact with and leverage our data assets. It makes data intelligence much more accessible.
So here's something to think about as we finish up. If these powerful large language models can be woven so seamlessly into our data platforms, automating insights, generating content directly from the raw data itself, what new questions does that raise about the very nature of data intelligence? And thinking bigger, how might this fundamentally start to change the actual roles and skills needed for data professionals moving forward?